Welcome to the first Shop Talk podcast, brought to you by your host, Burke Sanders. This is going to be a show where we discuss new and old technology. We will cover topics ranging from 3D printers, the topic of today's podcast, hand tools, all the way to AI and its place in your workshop. We will have many guest appearances where we interview a variety of builders, creators, and small business owners. All of this in hopes of helping others like yourself create the kind of shop and lifestyle where you can create the things you're passionate about. Thanks for watching, everyone. With that, let's begin today's episode. So today's topic is going to be discussing 3D printers and their place in your workshop. I began 3D printing when it first came out. I had the original DaVinci 1.0. It was a FDM printer with a single nozzle, single color, and it did not have automatic bed leveling. It was very difficult. It was very finicky. But it did give me a great introduction to the technology when it was still new and allowed me to overcome a lot of obstacles. Today, I'm currently printing with Resin Printers exclusively. Towards the end of the video, we'll go over comparing the pros and cons of printing with an FDM printer versus printing with a resin 3D printer. But currently, I use my 3D printers in my shop nearly every day. There is a steep learning curve, but it's also very beginner friendly. And hopefully by watching or listening to this show, you'll be better equipped to bring a 3D printer into your workshop with minimal fuss. I get asked questions all the time about 3D printers and how I use them, what they do, how they work. The goal here is for me to share that information with you so that if you as a new 3D printer owner, or if you're thinking about bringing one into your shop, is better equipped to hit the ground running on day one. Probably the most common question I get asked is, why do you have a 3D printer in your workshop? What's the benefit? Aren't those parts all plastic, cheap, and fragile? Don't they break? Well, let's go over that. So the very first point is that it's a very low cost of entry tool to get into. Any of you that own a workshop know that tools are expensive. 3D printers can be no different. However, entry-level printers, this is an Anycubic printer. I believe I picked this up on sale for a little over $100. It's got incredible resolution, which means it can print very fine details. It's a great printer to get started on for practicing. The one I use more often would be this Creality Halot Mage. And it is a very high resolution printer. It prints at 8K. And the reason I am currently going with this is because it has such a large build volume, which you'll see is very important when you're printing larger objects for a shop type setting. Even with this nicer printer, it was only about $500 to $600 brand new to get started with it. So it's comparable to most of your modern woodworking or metalworking tools at the entry level. Probably the biggest benefit of owning one of these is the ability to prototype parts extremely fast. You can take something that you have in your mind. This is a desk grommet for wire storage, and you can pull it up on your computer, stick it in the printer. It can be on your desk within 1 to 2 hours, ready to use. Now, it won't be as durable as maybe a store-bought version that's injection molded. However, I don't have to go to the store. I don't have to order something on Amazon, and I can test fit this piece immediately to see if it will fit. So the ability to rapidly prototype an item is great when you're in a shop where the design is constantly changing, where you have ideas on the fly and you'd like to test them out without spending a lot of money. So it can, by rapid prototyping, save you lots of money. The next benefit to having a 3D printer in your workshop is one step past prototyping. There's a lot of items where a 3D printer can actually print an actual functional part. We have storage boxes where this is as good as any item I can buy from the store. It's plenty strong enough. It will serve its function well enough without needing to buy one. Same thing for a lot of other things in my shop, little braces or mounts, this and that. Those parts can be created and you can skip having to buy them. So that's another way it can save you money. Next point I'd like to cover about why you would have a 3D printer in your workshop is it gives you a lot of customization options. So if, for instance, you have an item that you would like to buy, but it doesn't quite fit what you need it to be, with 3D printing, that allows you to create that same item and adjust it so that it fits your specific needs in a very precise way. Let's just go back to the desk grommet, for example. This is a 2-inch desk grommet. If you wanted to keep it low profile and maybe create a 1-inch desk grommet for USB cables or something larger for much larger plugs, you could do that very simply within a matter of minutes with the technology 3D printing provides us with. Customization is great. As far as like selling your own personalized products, if you want to put your name, if you want to put your logo, any of that, this allows you to do that with very minimal work and still have great results, just like if it were done professionally through a manufacturing shop. And finally, the last point of why I think you should have a 3D printer in your workshop is the educational value that comes with it. So we're in a world where things change constantly, and if you're not at the cutting edge, you're kind of behind. And so the reason I say educational value is we as creators and as human beings and as parents, as workers, as creators, as business owners, we need to stay relatively up to date with what's going on in the world, so that we don't get left behind and so we can have a competitive advantage in the marketplace. These tools, I believe, honestly, will be the future of how we create things. And if you're not at least taking a minimal step to understand how they work and how they can improve your lifestyle, then I'm afraid in 5 and 10 years, when these become the mainstay, you're going to be behind the curve. They're not perfect by any means now, but they are really good. And you can create some really amazing stuff. When these become a staple in every home and in every workshop, you'll have by far an advantage over anyone else trying to learn this technology for the first time. It's also a great way to entertain your kids or educate your kids on this technology. By the time they are our age, they will probably be learning these in school. This is going to be a technology that I do not think will go away. I think it will just keep improving and improving and getting simpler and simpler. And as such, I think these will be a staple of every modern home, of every modern workshop, of every school, of every college. And so it would be in your best interest to go ahead and start accepting this technology and bringing it into your life ahead of time, so that you're able to really keep up with those changes, use them in a positive way in your life. So now that you know why I recommend you have a 3D printer in your shop, let's go ahead and briefly touch on the different types of 3D printers. There's two main types right now that hobbyists and most workshops would be using, and those are resin printers, which include quite a few different types. It's mostly SLA, DLP, and LCD. That just refers to the technology that they use to harden the resin that creates your 3D object. The other type of 3D printer that you most often see is an FDM printer, or a fused deposition modeling printer. This takes a solid material, melts it, and recreates the item that you're trying to create on a build plate. They work similarly, but they have distinct differences. The show today, because I've specifically switched to only resin printers, and we'll go over that a little bit later as to why, is going to focus on resin printing. But a lot of the information in this video is going to be applicable to FDM printing. So don't just click away because you don't see FDM printers here. I've owned plenty of them. I've used them. They work great. However, just in the stage of where I'm at with my shop and what I do, these printers are a better fit for me. With that, let's move on to the next most common question I get asked, which is, well, how do you use a 3D printer? That seems overly technical. It seems difficult. It seems like I'd have to learn a lot. It's really actually a simple process. There is a learning curve, but it's something that we can all pick up, and I think we can all do relatively well. I'll walk you through the steps, going all the way from how you get a 3D file to how you actually put it on the printer, take it off the printer, and get to where you have a physical object in your hands that you can use in your shop. For those of you that are listening, I will do my best to use descriptive words. However, this is primarily a video podcast, so if you would like to watch it, please check out our channel. It'll be linked in the description. Otherwise, it's still useful information. You just won't be able to see the visuals as we discuss how this process works. All right, with that out of the way, let's go ahead and move on to the process of actually creating a 3D print using a 3D printer. We'll cut over to my computer screen, and we're going to keep this simple for today. So you're going to want to use initially, while you're learning, a website like Thingiverse or similar, and we will find a 3D file that we want to print. They have tens of thousands of files available for you to download and use free of charge. So what you'll want to do is click on any one of these items. All right, here's a simple cable holder that we might be able to use. So we'll go ahead and show you how you would take this all the way to the point where you have a physical object. So you're going to click either download all files, or you can come down here to where it says files and see how many files there are and actually download just the files that you want. So this one only has one file. So all we have to do is download that one file. So we're going to save it to our desktop so it's easy to find, and we are going to minimize this screen. At this point, it's important to note each type of 3D printer typically has a different software that you would use to print the file with. Creality has its own software. There are third-party softwares, which is what we will be using today. Specifically, we'll be using a software called Chitubox to send these files to our printer. So we open the file into Chitubox, and first thing you need to do with a new printer is add it to your profile in your software. So as you can see here, I have my Halot Mage, my Creality LD002R, and my Anycubic Photon Mono 2 here. Those are the 3D printers I currently have and that I currently use. So make sure that you've added and have correctly selected the printer that you want to print on. This will determine the build plate size that's available to you while orienting and supporting this file for 3D printing. So at this point, you have your file in the software and you're ready to move on to the next stages. With resin printing, the orientation of an object determines, one, how it will be supported, and two, the length of your print. So just for example, this item here, while laying flat on the bed, if we go ahead and get it ready to send to the printer, it projects that it will take roughly 1 hour, 8 minutes, and 57 seconds to print. Now, if we simply rotate the object so that it is standing vertically, and we do the same thing, it's going to now take 5 hours, 41 minutes, and 5 seconds. The reason I show you this is that it's important to know that with a resin printer, compared to an FDM printer, the length of print is determined by the height of your object. A resin printer can cure an entire bed, an entire build plate surface layer all at once. So it doesn't matter how full your build plate is, it matters how many layers it has to cure in the vertical orientation. So the higher your object goes, the longer it will take to print. So with that, we can adjust our prints so that they lay relatively flat on our print bed and reduce the printing time needed to print those objects. The next thing we want to discuss is adding supports to your object. This can be as complicated or as simple as you want to make it. There are benefits to taking extra time to doing it yourself. However, in most workshop settings, unless you're developing a final piece, it's not necessary to finesse every support you place. And in fact, most softwares have an auto support feature. I'll show you that now. You can choose based on the size of your object and have some preset defaults whether you want to put light supports, medium supports, or heavy supports. Light supports are going to be great for things like printing miniature 3D models. A lot of people really like to do tabletop game 3D prints with these resin printers because the resolution is so good. You can get high quality prints, and with light supports you get minimal surface finish irregularities where those supports contact the print. If you're printing something larger or something that doesn't need to have pristine surface finish, then you can either add medium or heavy supports. When I'm in the shop, almost always with larger items, I'm going to go ahead and add auto supports that are heavy. I'll go ahead and show you that now. All you have to do is click Add All. It's going to go through the print and it's going to determine on its own where the supports need to be to make this 3D print successful. Without getting too deep into it, anytime you have a flat surface like this on the bottom, it's best with resin printers not to print them directly on the bed, as your first few layers need to be cured longer than the rest of them. So that will create kind of a warped structure. Actually, I want to remove those and show you one other thing that is important to keep in mind. So if you print it flat like this, you're going to have some a lot of supports on this bottom flat surface area. And that's okay because you won't see it for this particular object, but if you wanted to keep the object as smooth as possible, what you would want to do is rotate this item at an angle. The reason for that, roughly a 45-degree angle works well. The reason for that is that each layer can build up on top of itself, and you won't have a really rough finished bottom layer from where all the supports have to initially connect to make this bottom layer flat. So it's always a good idea, even if it adds a few minutes to your print time, to angle your 3D print so that you don't have flat surfaces parallel with the bed. So if we go back to our supports, we add our supports. You know, as you can see, it changed the layout of the supports, but it still added all the supports we would need. At this point, we could take this 3D print file and we can go ahead and slice it. Now what this means is it's creating a file that your 3D printer can read, it can understand, and it will be compatible with your 3D printer. From this point, it's as simple as saving the file and adding it to a USB thumb drive and starting your printer. For this demonstration, I actually have a different file I would like to print. So with that, follow me over to the printer and we'll go ahead and show you how to start a print on the 3D printer. All right, so once you have your file on your jump drive, you'll come to your 3D printer and you'll insert the thumb drive. Some printers do have Wi-Fi technology. I don't find this is very useful for me personally. You'll select your print and you will click print. There are some setup procedures that you need to go before you can successfully do your first 3D print. However, that's not in the scope of this video on setting up a 3D printer, and you typically just need to follow your manufacturer's recommendations on how to set up your first 3D printer. I will let that run in the background while we continue on with the video. Because it takes a little while to print a 3D print, we're actually going to use an item from this 3D printer to demonstrate how you would remove a 3D print once it's completed. Its build process. So typically, resin printers will have a cover that is UV blocking to keep the sunlight out. This needs to be removed, placed to the side, and you will need to remove your build plate from the printer. Most of these have a single screw where it can be removed and set in a place where you can work on removing the print. At this point, the best tool for the job is going to be a simple scraper. Most printers will come with one of these. However, if not, one can be picked up relatively cheaply. I print rafts under mine so that they're easy enough to slide the scraper underneath, and they will pop off your build plate relatively simply. At this point, I like to scrape my build plate just in case there is any residual cured resin on it. Give it a quick wipe. If your build plate is clean at this point, my experience has been that it's perfectly acceptable to place this right back on your printer and continue printing without needing to clean the build plate itself. Once it's completed, go ahead and replace your cover so that UV light isn't hitting your resin vat and interfering with the resin that remains in the printer. At this point, you have the 3D print with its support structure still intact. Now, depending on how well your supports are placed, majority of the time, these are as simple to break off as pulling on them with your fingers. However, for larger objects, like I recommended placing larger supports, this is not as simple a process as breaking them off, and you may need a set of pliers design small objects with that. And with that, you can simply clip the supports as you go around the object to remove it from its supports. So we'll go ahead and skip through this quickly as I remove these supports from these prints. Again, it's a simple process the majority of the time. With that, you have the remainder of your supports, which can be thrown away in the trash. At this point, you may have small bits of supports that remain on your print. That's okay. We'll still take our clippers and clip those remaining little bits off. It's also perfectly acceptable at this point to use a little bit of sandpaper and rub those down. However, I would recommend putting your 3D prints through your wash and cure process before sanding them, as to preserve your sandpaper's life. It makes it last longer if you don't get the wet resin inside your sandpaper. So I'll briefly clean these up, and then we will head over to the wash and cure station, which unfortunately I could not fit on the desk, and we will demonstrate how to go ahead and clean up a 3D print so that it is ready to use for whatever task you've printed it for. All right, so I had to cut over here to wash and cure these. So this is my wash station. It's as simple as dropping your prints into the basket, dropping the basket back down in. Now this wash uses isopropyl alcohol. Depending on the resin you choose to use, you could use water. However, I use isopropyl alcohol dissolvable resin. So we're gonna make sure we get on wash mode, and it's as simple as hitting start there. If you don't have a wash machine, you can literally just use a tub with isopropyl alcohol in it, soft toothbrush, something like that to scrub it clean. Works just as well. This is just hands off, automates the process a little bit. So I'll let this wash this. I run it for about 2 minutes for this size part, and I'll come back to you, show you after it's washed, and then what the cure process looks like. All right, so now the washing portion of this is done. We will just pull this basket out. I like to dump it on a paper towel for just a second. While I get rid of this. And the cool thing about these washing and curing machines is they can do both things on the same machine. So it's usually a good idea just to kind of prevent and preserve clarity of these, is to let the isopropyl alcohol dry before you cure them. These are literally just test pieces for this this video, so I'm not too worried about how they turn out. So we will throw these on here, and I will demonstrate to you how you cure these. And it's a simple matter as putting the lid back on, turning it to cure mode, and clicking start. This process runs for roughly 2 minutes as well, and after that your 3D prints will be done. I would like to mention, however, on flat objects like this, typically I will pause the curing process at about 1 minute mark and flip them over to the other side. That way they just have a chance to cure evenly on both sides. Again, since these are test pieces, I'm not too worried about it. I just did them to show you guys how simple it is to go all the way from something that you have on your computer to a physical item that you can hold and use. So as soon as this would be done, I'll just stop it here. You could take these off, and these are technically usable 3D prints at this point. So very rigid, and you could do a lot with this. So anyhow, I'll go back over to my other camera. All right, and just like that, we have our 3D prints cleaned up. These are specifically John Wick coins, the coins from the John Wick series. I wanted to build my kids a small treasure chest and include some fun coins to play with. And so, yeah, that's what these are. Let's move on, guys. All right, I'm just going to cut in this video and do a small takeaway section. I get asked a lot what printer I recommend for you to have in your workshop. And the answer varies. It depends on what you want to do, how you want to do it, and the results you want to achieve. However, a printer I can strongly recommend is the Creality Halop Mage. They have the regular version and the Pro version. Subtle differences between the two. However, the main takeaway, so you got a 10.3 inch LCD screen, which for me has functioned flawlessly. When it first came out, there were a few errors with the software reading 3D print files, and that's expected with new hardware, and that was cleared up relatively quickly, and I haven't had problems with it ever since. The main benefit for me with this printer is it allows me to print very large items in my shop. Smaller printers, um, like the Cinecubic here, the build plates or what you create your item on. And your volume of what you print is limited by the size of your build plate. So if it will not fit on this build plate, you cannot print it in a single print. There are workarounds where you can break up your prints into multiple pieces. However, for simplicity's sake of this show, we'll just say that if it won't fit on the bed build plate of the printer, then you won't be able to print it. The Mage, however, as you can see, has a much, much larger build plate. So I'm able to, from the beginning, print much larger objects than I could with some of the smaller 3D printers. That is the primary reason I've gone with this printer. As far as why I choose to use Resin 3D printers over FDM 3D printers is because of the resolution of the objects. FDM printers, while they've come a long way and they're getting more and more competitive with resin printers, the resolution of your print, meaning the ability to see layer lines, is going to be drastically different between the two printers. Resin printers with the appropriate settings can print objects that come out perfectly smooth with invisible layer lines. You won't be able to see where the material was fused together. FDM printers, even the best ones I've seen, still have small layer lines that are visible throughout the print. And that's just the difference in technology. There are pros of FDM printers over resin printers, and we'll discuss those later. But for me and my recommendation, anyone getting into 3D printers, I think the future is going to be resin printing. I think it's going to be simpler in the long run, and I think that in your workshop, if you're wanting to develop high quality parts, then a resin printer is going to be what you should probably go with, because I think that will eventually be the future of 3D printing. So with that, the next question I usually get asked is, well, if I have to wear gloves and all this, isn't resin toxic? Why would I want to bring that into my shop? How safe is it? What is it made out of? I don't like to have chemicals that I don't need to in my shop. So yes, resin can be a skin irritant. Different resins have different levels of health hazards. And so it's important to refer to each specific resin's safety data sheet. That'll let you know specifically how dangerous the resin is. I would say the vast majority of resins out there have minor health concerns. And with that, I mean that they are skin irritants. They will irritate your skin if they come into contact with it, especially if UV light is exposed to the resin while it's on your skin. So, what is resin? It's a combination of different substances. So I don't have this stuff memorized, guys, but I did print it off so that we could talk about it. Resin is a substance they call a photopolymer, meaning when it's exposed to a UV light, it will harden. The way this chemical compound works is it has multiple components. The main components in a resin are a monomer and a photoinitiator, along with other additives that will give your specific resin the properties specific to that type of resin. So a monomer, those are basically the main building blocks that make up what your 3D print is. The photoinitiators are things inside your resin that when the UV light hits, it kind of creates a chain reaction and causes the resin to harden. And all the rest of the stuff that's contained inside your resin is what gives it its strength, its flexibility. It determines how brittle the object is, and those can be modified. Specifically, the main safety concerns with a resin is skin contact. Again, we kind of covered that before, but it is a skin irritant. It can cause rashes. It can cause a burning sensation when it's on the skin. It's sticky. So you always want to wear uh, PPE, gloves, avoid getting it on your skin if at all possible. And if you do, rinse it off relatively quickly so that it doesn't have time to irritate your skin. It is dangerous to your eyes. It's always a good idea to wear eye protection when dealing with chemicals. Resin can cause permanent eye damage if it gets into your eyes. So it's always a good idea to wear safety glasses. Most of the time you're going to be fine if the resin gets in your eye, to rinse your eyes with fresh water for a few minutes and then move on. However, it's best to avoid that situation in the first place by wearing eye protection. Um, final 2 points. Resin can be a pulmonary irritant. So the fumes from resin 3D printers vary resin to resin. However, most of them have a fairly minor to moderate noxious odor associated with them. And I don't think there's a lot of great information over the long-term effects of inhaling those odors. However, they can, just like they irritate your skin, irritate the linings of your lungs and cause inflammation. They could give you a cough. So it's always a good idea when you're 3D printing to have your 3D printers in a well-ventilated area, somewhere away from the family, somewhere away from the main part of your workshop, somewhere that you can open a window or ventilate the 3D printer to an exterior place. The Halot Mage has specifically an exhaust fan built in that you can duct with a hose um, its exhaust to somewhere safe. Another reason that printer gets a big thumbs up in my book is that it does what it can to keep the fumes out of your workshop. And finally, the last thing is, the long-term effects of resin um, aren't really known. Many of the chemicals that are inside of resin um, have been labeled as carcinogenic, which means they have the potential to increase the likelihood that you may develop cancer. Um, However, that's being a little bit harsh. A lot of chemicals that we deal with on a day-to-day basis um, are carcinogenic to an extent. So I think as long as we follow basic safety precautions, limit exposure, limit skin exposure, limit respiratory exposure, then you're going to be fine with the printing. Make sure you're in a well ventilated area, guys, and I think that'll be just about all you need to do to keep yourself and others safe when around these printers. Then I'd also like to talk a little bit about disposing of uncured resin. So just because of the safety concerns with resin, it's typically a good idea to not pour uncured resin down the sink, down a drain, down your toilet. You don't want to introduce this into any water source. A good method to dispose of uncured resin is to place it in a jar or a container and set it outside and let the sunlight activate it so that it becomes an inert compound. And then you can throw away the solid portion of the resin in your normal trash, and it can be disposed of as if it were something as simple as a 3D printed object, which can go directly in your trash. All right, so next question I get asked a lot is somebody has taken a step towards 3D printing in their shop, and they say, well, can you give me some tips for how to improve my 3D printing or stuff I need to know before getting into the printing process? And so I've come up with a list of 21 tips that I think everyone should know before they start their journey into 3D printing. Um, the first tip I can give most people is to keep your printer in a stock configuration, to use a resin that is designed for your 3D printer, and to print away just like that without making any modifications or changing your resin between prints. There is a lot of modifications and resins out there, and the problem with switching too early is you don't learn what your printer can and can't do and what your resin that's made for your printer can and can't do. So you don't ever develop a baseline um, that you can reference or go back to if you start having any problems. So I think it's very important for everyone starting out in the 3D printing community is to just really focus on dialing in the printer that they get with the resin that it uses, and learning that to the best of their ability before moving on to more complex or different resins, different prints. Stick with simple stuff, and over time, you'll know when you're ready to try something different, and you'll be safe and confident in doing so, and you'll have much better results and a lot less print failures. The second tip I'm going to give everybody is along the same lines as the first, is that you should take extra time in learning how to dial in a resin printer's exposure settings. The way a resin printer works is it shines a light on the bottom of the resin and it hardens it for a specific length of time. Each printer requires a different amount of time based on the strength of the light, and also each resin requires a different amount of time depending on the resin. So when you get a new 3D printer, it's a great idea to start off with high exposure settings. With each subsequent print, back it off just a little bit until you get the quality of 3D prints that you're looking for. There are also a lot of tools out there designed to help you dial in the specific exposure times for your 3D prints. You can check out my channel, I Can Build That, and there will be a tutorial on how to do this for a 3D printer. And I think if you'll follow that step, you'll have infinitely less failures. And this step does need to be done for each new printer and each new resin. However, the good thing is that once you know your settings, you can record them and you can use those settings as a baseline from then on out for that particular printer combination with that particular resin. It seems like a lot of extra work, but when you're putting 10 to 20 hours into a large print and it doesn't fail, it's well worth taking the extra 2 to 3 hours it takes to figure out the correct settings. So my third tip, and again along the same lines, is when you're printing in a workshop and you're printing large items that aren't small minifigures or miniature pieces that don't have much weight to them, you don't need heavy supports for the small stuff. But when you have a big item that has some heft to it or some weight, you're going to want to overexpose that print. And the reason for this is this print has a lot of weight to it, and it has a tendency to either separate itself from the bed or separate itself from the prior layer line just because of the amount of weight the material is placing on itself. So it's a good idea to find your base levels of exposure time, and from there, depending on the size of your print, increase those settings to accommodate for the additional weight. This will reduce the quality of your print slightly. However, my experience has been that it is negligible and it's well worth it in order to get successful prints. My fourth tip is going to be to make sure you have proper ventilation in your shop, in your home, in your garage, wherever you choose to keep your 3D printer. The smell of the resin varies resin to resin. However, most all resins have a pretty terrible smell to them. So you're going to want to make sure you can open a window, install a fan. Some of the more modern printers actually have exhaust ports where you can route a hose to ventilate it away from the areas that you're going to be in. Tip number 5, always wear your PPE, guys. Always use plastic gloves, always have eyeglasses. Try not to get it on your clothes, as if the sunlight hits it and it cures in your clothes, it can permanently damage your clothes. We all just want to be safe. It takes very little extra effort to be safe with this specific tool. And so, you know, play it safe, guys. Use the PPE, and that way we all have a good experience doing this and it doesn't develop a bad reputation. The next tip I have for you guys, when setting these printers up, the build plate needs to be perfectly level with the screen that is going to be curing the resin. This is known as leveling your build plate. And so we want to take extra time with a resin printer the first time we set it up to make sure our build plate is level. The big advantage of this printer over an FDM printer is that you can set this bed level one time and forget about it unless you start having problems. So really make sure when you're setting up your printer for the first time, or if you're having problems, you follow the manufacturer's instructions and level this bed in the best possible way, and you'll get some great prints as a result of that. Tip number 7, guys, you're going to have periods where you're not printing very often. Your resin's going to sit in its resin bottle and it's going to separate just like any other solution would if you don't use it for a long time. So before you use your resin in your Resin 3D printers, you're going to want to make sure you mix it very thoroughly. This makes sure all the polymers in that solution are spaced evenly, ready to go, ready to give you a good 3D print. And that goes for resin that you leave in your bed of your printer. If it's set there for a few days, guys, go ahead and get a really soft bristle paintbrush, a plastic stir rod, something that won't scratch the screen of your 3D printer, but that you can mix the resin around inside the vat so that it's well mixed. If it's not well mixed, guys, you're going to have print failures, you're going to have poor print quality, and it's just going to be no fun. So that is something you need to be mindful of, how long your resin's gone without being agitated. If it's been a while, go ahead and mix it up. It's okay to pour your resin out of your vat back into the bottle and give it a good shake. In fact, I would recommend that if you have time. That's just going to give you so much better results long term. Along those same lines, as tip number 8, is you're going to want to filter your resin frequently. When you buy resin, it's going to come with these coffee filter looking filters. And I recommend that anytime you add resin to your printer, you pour it through one of those filters. And also, anytime you remove resin from your printer and put it back in the bottle, I also recommend that you run it through one of those filters. The reason for this is occasionally we have parts of our 3D print that flake off, that break off. If you have a failed 3D print, you're going to have a lot of gunk in your resin, and you're going to need to keep that out of the resin vat so that it doesn't get compressed between the build plate and the screen. That can lead to all sorts of problems, as minor as a failed print, as major as breaking your screen. So you always want to make sure your resin is nice and clean. It doesn't have contaminants in it. It doesn't have parts of failed prints. Moving on to tip number 9, you're going to want to place supports wisely on your 3D print. It's easy to want to hit the auto support button and just be done with it. However, think about how your 3D print is going to be viewed when it's in the real world. If you're printing something like a desk grommet, maybe don't put supports on the visible part. Support it from the bottom so that the support deformities that get included in your print aren't visible. If you're printing a character figure, put the supports on the back so that when you're looking at it from the angle that you would typically look at a 3D model from, you won't see them. So just be mindful of where your supports are going to go, because they don't always, but they do sometimes cause minor surface imperfections, which ideally can be hidden so that you don't have to deal with them. If you don't, it's just a lot of extra cleanup work. It's a lot of extra filling work if you're going to make those surfaces mirror smooth, or if you'd like to polish them up a bit. Tip number 11 is you're going to want to over support large objects. So when you're printing something small, you can use a small amount of supports. There's not a lot of weight. There's not a lot of vertical force being put on that object every time it raises and lowers the print bed. However, when you're printing something very large that has a large surface area, it's going to pull a lot of force as it's pulling it up off the build plate every time. And so what that does is that increases the tension that this undergoes every time on each support. So if we only put 3 supports on this object, all that pressure is going to be pulled across 3 points, which leads to an increased likelihood of your print failing. You know, overbuild supports on heavy objects. Put a few hundred, put a lot. Make it so that you can clean up a few support spots versus having to clean up your resin vat because your whole print failed. Increase your supports for large objects, guys. That is going to save you a lot of headache. If you're using a printer in a shop, you're probably not printing minifigures that weigh absolutely nothing. You're probably trying to print functional parts that use a lot of resin. So it's going to save you guys time and money just by adding extra supports to the big stuff you print. All right, tip number 11. When we are washing our 3D prints, that removes all the uncured resin from our prints. The life of your isopropyl alcohol that we use to wash these objects in is very dependent on how much resin it has to clean off. So over time, the effectiveness of your wash station or wash bucket, whatever you're using, it will deteriorate over time. So the tip is when you're going to wash a 3D print, go ahead and remove a lot of the support structure before you place it in your wash bath. That will reduce the amount of resin that needs to be dissolved from your object, and that will increase the life of your isopropyl alcohol or water, whatever you're using in your wash bath to clean these prints up. Tip number 12, guys, is if you're worried about your surface finish quality, you can still add thick supports, and my recommendation would be to cut them long before you wash your item. And the reason for that is if you leave the supports long, you wash your item, then you can simply sand those supports down to even with the surface level. That way you don't have divots that you need to fill. It's a lot easier to sand them down than it is to break them off and try to fill in all the little voids that might leave down the road. So take a nice pair of sharp cutters and cut the support just a little bit above surface area. And then once you wash it, once you get it cleaned up, you can easily sand that down with some sandpaper or a file and get it to where it's a perfectly smooth surface. Tip number 13 is going to be to sand your supports or any imperfections you have that you need to sand before you cure your 3D print. Once you cure the outer layer of your 3D print, it creates a hard exterior shell on that print, making it a lot more difficult to remove material. Go ahead and wash your print and sand down any major surface imperfections and then cure your print. This will save you time in the sanding process. Nobody, I don't care who you are, likes to sand, and so that's going to make that step take less time. Tip number 14, keep an eye on your print process. It's okay to walk away from your 3D printers, but when you're getting started, you want to watch your printer for failures. You want to watch it for errors. That way you learn the printing process. As you build confidence, you can leave your printer for extended amounts of time and know with a high degree of likelihood that your printer is going to succeed in the print. However, when you first get started, it's very likely that you'll make a few mistakes, and you'll want to catch those as early as possible to save time, to save money, to save resin, and to hopefully prevent any problems that may occur with a failed 3D print in the resin printer. Tip number 15, guys, when you're washing your 3D print, try to use a high concentration of isopropyl alcohol. They have different concentrations ranging from 50% all the way up to 100%. I personally recommend using 99% or greater isopropyl alcohol. This will increase the effectiveness of your cleaning, and it will also keep your concentration strong as it evaporates from the solution. So alcohol will evaporate faster than water. If you're buying 50% isopropyl alcohol and 50% of it dissolves, then you have, or evaporates, then you have a 25% isopropyl alcohol solution remaining. If you have 99% isopropyl alcohol, 50% of it dissolves, you still have roughly a 99% concentration isopropyl alcohol in your wash station. So it costs a little bit more to use the higher quality isopropyl alcohol, but you'll get much better results. Your solution will last much longer, and you'll have less problems in the cleanup phase of 3D printing. Tip number 17, make sure you cure your 3D prints after printing them and washing them. I use a curing station, which means that it's got a built-in UV system to shine UV light on all surfaces of a new 3D print. This can be done by setting your object outside in direct sunlight. This will also cure your object. No matter what you do, you don't want to skip this step, as it will leave a tacky surface finish on your 3D print, and it will reduce the overall life and strength of the item that you've printed. Tip number 18, make sure you store your resin in a UV protected bottle. The bottle that your resin comes in is a great place to store it. Keep it out of direct sunlight, keep it away from extremes in temperature. Resin does have a shelf life. And so you'll want to do all that you can to promote that resin lasting as long as possible. And the best way to do that is to store it in the bottle that it came in with the lid tightly secured out of direct sunlight. Tip 19, you got to dispose of your resin properly, guys. It seems like a pain that you can't just pour it down the sink, but we all want to be responsible creators and builders. And so take the extra step, go ahead and buy yourself a bucket, keep keep waste resin in that bucket, and once in a while take it outside and let it cure and throw away the cured resin into your trash. It's as simple as that. It's an extra step, but we want to leave the world a better place for all that follow in our footsteps, and we don't want to be dumping toxic chemicals out into the world if we don't have to. Tip 20, if you're going to make an item that will be mass produced, something that you're trying to sell, something that you want to get out into the world that you want to make a lot of copies of, go ahead and take time to tweak your supports and your orientation of your 3D printed item in the software that you're using. The reason for this is you can reduce your print time by perfecting your orientation, and you can reduce your cleanup time by modifying the way you support an item. Sometimes items need to have really heavy supports. Sometimes they can have medium supports. Sometimes they can have light supports. And by minimizing the amount of supports and the type of supports on these mass-produced objects, you can actually decrease your overall time needed to get from a design to sellable products, which is multiplied for each product you design. If you're doing a one-off, it doesn't matter as much. However, if you can save an hour on an item that you need to print 300 times, that's a lot of time. And so keep that in mind. You can tweak settings and spend an extra hour in the software before you print, and it will save you countless hours down the road when you're printing large volumes of the same item. Tip number 21, final tip. Pick one well-rounded software that's compatible with your printer and learn it. Don't try to learn 3 different softwares. Don't try to learn how to support in different softwares. Same as learning your 3D printer for the first time. You want to learn one software for the first time. Learn what it can do, what it can't do, find out its limitations, find out your limitations. Once you've had a few months or a few dozen prints run through that software and you feel comfortable modifying your supports, modifying your object's orientation, once you feel comfortable that you have developed the skills to successfully print over and over, it's okay to start venturing out into different softwares, trying new things. However, in the beginning, when you're first learning, it's really important to try to make this a fun hobby, to make it a successful hobby. And I think the best way for all of you to do that is going to be to stick to one printer, stick to one resin, and to stick to one software and learn it as best you can before branching out. The next question I get asked most frequently is, should I go with a resin printer or should I go with an FDM printer? We're going to go through 10 categories where I compare each head to head and pick a winner for each category. And at the end, I'll tell you why I choose a resin printer over an FDM printer, but this should allow you to make a educated choice when picking which printer is right for you. So the first category of competition is print quality and detail. FDM printer versus resin printer, which is better? Resin printer is going to win this hands down. They have much finer degree of accuracy when printing. You're going to get much better looking objects. You're going to get fewer layer lines. FDM technology has improved substantially, but there is a clear winner in this category, and that's going to be a resin printer. The next category is how smooth of a finish can each one deliver. And again, this will be your resin printer. Its high quality nature of printing just provides better surface finishes despite having to provide supports. If your goal with 3D printing is print quality, you're always going to be better off with a resin 3D printer. The next area of competition is going to be which printer can print very small miniature objects better. So if you want to print minifigures for Dungeons and Dragons tables or desktop games, again, the winner here is going to be your resin 3D printers. They have much higher resolution printing ability, and you're going to get much better and more accurate miniature printings done with these types of printers. Fourth category is going to be strength and durability. Now, as much as I want resin to win them all, FDM printers are going to take this one in a landslide. Resin printing's come a long way. However, the filament that they use in FDM printers tends to be stronger, tends to be less brittle. There is definitely more types of filament out there at the moment than there are resins. So if your only goal is how strong and how durable will this item be, then an FDM printer may be for you. As far as safety and odor of 3D printing, that's going to go to FDM printing as well. It's got less odor. It's a lot safer item to handle. You don't have to deal with liquid chemicals. The biggest risk with FDM printers is that there is high temperatures involved to melt these materials, and so there is a small risk of being burned. Otherwise, for the most part, they're relatively safe. Resin printers, the resin can be an irritant. It can possibly have long-term health consequences if you're exposed to it improperly. So FDM wins this competition. Next area of competition is going to be the cost to operate. FDM printers are going to win this. Resin printers lose this not because the printers are more expensive or that the resin is more expensive, but because you have to have additional chemicals and things to keep your resin prints cleaned after they're printed. And you have to have a curing station, so those add additional layers of cost. If you just want to print for as cheap as possible, FDM printer takes the win, and that's what you want to go with. Next area of competition is going to be ease of use. FDM printers, I probably would have not given this a few years ago. However, I'm going to give them the win here now that they have auto bed leveling technology. It used to be such a pain to level the print bed of an FDM printer. Now most of those can handle that themselves. Resin printers, their bed is almost always level, so you almost always have great prints. However, you do have to deal with adding supports to nearly every print. You also have to deal with the cleanup and curing process. So we're going to give that win to FDM printers. Next area of competition is going to be speed of print and print time. This one is going to be a toss-up, I think. It depends on what you're printing and how you want to print it. If you're printing very small flat objects, then a resin printer is probably going to be faster. If you're printing big, complex objects that are really tall, it's probably going to be a tie. If you're printing not complex objects that are tall, that are skinny, that are simple, like a vase, then your FDM printer is going to blow away your resin printer. So depending on what you print, you may want to go with an FDM or you may want to go with a resin printer. I don't think there's a clear winner here unless you give me a specific item to compare. Next area of competition is going to be material variety. Resins come a long way. There are dozens and dozens of different types of resins for your 3D printer, giving you a lot of options out there. However, there are hundreds and hundreds of different types of filaments for your FDM printers out there. You've got carbon fiber, you've got rubber-like, you've got very hard, you've got very soft, you've got flexible. If you want to be able to print a larger variety of materials, then you're going to want to go with an FDM printer. If you just need one type of material, then I think a resin printer would be fine. However, there is a clear winner here at the moment, which I think this gap is closing, but FDM printer takes the win for the material variety that you can print with. Last area of competition is going to be the detrimental environmental impact from using a 3D printer. We all want to be environmentally conscious. Which one is worse for the environment? At the moment, resin 3D printing is worse for the environment. It takes more supplies to do. It takes more chemicals to make it happen. And so you have more waste. You have more byproduct from the printing process. So if environmental concerns are your primary reason for picking a printer, then you want to go with an FDM printer. So that being said, FDM printers seem to have more wins in this competition. However, I still use a resin printer. Why is that? The reason for that is most of the areas where resin printer falls behind is something that I can offset. Print time, for instance. How long it takes for something to print doesn't really matter to me. I'm not in a rush to get things printed. I'm not mass producing objects, so I can wait on something to print. Print material variety. I've had no need to print anything that I couldn't print with a resin printer. They have flexible resins, they have transparent resins, they have every color resin you can imagine. For me, at least, I haven't found a project that required a type of printer material that I wasn't able to do with the resin. Ease of use, maintenance. I've got a lot of experience printing, so it's natural that I'm more comfortable with a complex process. That doesn't scare me away from using the resin printers. However, if you're new to printing and you want a simpler process, maybe an FDM printer would be an ideal choice for you, but it's not a reason for me to shy away as far as choosing my printer. Final category, which I feel like can be offset, is the health safety issues. Yes, this is a more dangerous type of printer to work with, but it's all relative. Compared to my table saw, this is a fairly safe gadget, and you can offset the risks by taking proper precautions, wearing gloves, making sure that you're in a well ventilated area, ventilating your printer out somewhere where it's not going to have any health concerns. And so, for all those reasons, I think it's in my best interest to use resin printing in my workshop. However, it's up to you to make that decision for yourself. I highly recommend resin printing, but I also highly recommend FDM printing. It's just too much for me to keep both materials in stock on hand to try to keep up with them. And so I chose to simplify it and go to one type of printing system. This has worked well for me. Sometimes I feel like I'm limited by my print volume. I feel like FDM printers typically have a larger print volume. However, if you want to spend the money, you can buy large print volume resin printers. You're just going to pay a little bit more money for a larger print area comparable to an FDM printer. All right, guys, who do you think won? What kind of printer do you prefer? Let me know in the comments. I'd love to hear your thoughts. I'd love to see which printer you think is best to be used in a workshop, where you print a variety of things, where it's a different project every day. Let me know. All right, last thing we're going to cover in today's video podcast, is what we think the future of 3D printing will look like. And I personally believe that there will be a 3D printer in every home, in every shop, probably within the next 10 to 15 years. The technology these things have is incredible. They open so many doors. They're fun for kids. It's easy to print little trinkets and gadgets for them, and the technology is only going to get better. As far as outside of the workshop, I mean, they're already using 3D printers for dental implants, for Invisalign, for printing medical devices that are human body and person to person specific. We have 3D printers now that can print in metal, that can print aerospace designs. So I think this technology is only at its baby steps of entry, and I think over the next 10 to 15 years, especially in the home and workshop space, you're going to see dramatic changes that are going to open so many doors for us to be able to create new things. Just imagine how hard it is to take a design and have it created into a solid block of aluminum. I mean, you got to take it through a milling process. It's complex, and so wouldn't it be cool if we could just click print, come back 5 hours later, and you've got a metal printed 3D object that has the strength to endure harsh environments, rough conditions, something that you could use on your vehicle, something that you could use out in the wilderness. It's just an amazing field that I think is going to keep getting better. I think you guys should, if you're not going to take the leap into 3D printing, you should at least keep your eyes on it. You should at least try to stay up to date with it, because I think no matter what you do, no matter what field you're in, I think it's going to start crossing over into all the lines, guys. Advertising, you're going to be able to print little advertising trinkets, medical. It's already opened a world of possibilities in medical. As far as building stuff, I mean, that's going to be its bread and butter, guys. You're going to start to be able to print items out of multiple materials, um, differing strengths, differing, and you're going to be able to go from a complex process down to a simple process to get the same item. And so you're going to start saving time. You're going to start saving cost. And so it's going to open a possibility where we can have things built and created so much more personal and so much more cheaply and quickly. Just think of it like this. One day, I imagine you'll be able to buy something online, click buy, you can have it delivered, you can have it drone delivered, or you can have it sent to your printer to be created. How cool would that be? I mean, you won't be able to do it for everything for a while, but I imagine within the next 15 to 20 years, there'll be stuff like that out there. I can already, if I need a carpenter square, if I need some type of small device, I can pull up a file and I can print it, and it can be ready to go within an hour or two. I think 3D printing is going to be a wonderful addition to your shop, guys. If you haven't dipped your toes into it yet, it's a low cost entry point. Have fun with it, build some cool stuff. Let your creativity go. See if it's something you can use. If it's not there yet, then come back to it in a few years. I think you'll be able to take your shop to the next level if you include 3D printing as one of the tools in your workshop. With that, guys, thank you for watching. I appreciate you if you stuck with me this whole time. For more specific tutorials, check out our YouTube channel. I can build that. And with that, guys, I'm signing off. Be sure to come back next week for our next podcast. And until then, guys, enjoy and build some cool stuff.